Hello everybody. We have already provided two separate solutions to this problem, system of equations, system of linear equations, I should say. And the first solution was the method that you guys learned in middle school, I guess, related to substitution. The second method was the new linear algebra language, matrix notation. And now the third solution. Our third solution will be based on something called determinants, and we have some video content where you can refer to that. But just to remind you, if a matrix, say A, is a 2 by 2 matrix, say A, B, C, D, then it turns out that the determinant of that matrix is simply equal to, we just multiply A and D, A times D, and then we subtract from it the product B times C. So that would be the determinant of that matrix. So this is just a reminder. So based on this definition, now we can solve this problem pretty efficiently. It turns out that the value of the two variables, x and y, depend solely on the 6 numbers given in the problem. So we want to calculate the value of x and the value of y, and we have 6 coefficients that you guys can see in these pairs, in this system of equations. And it turns out that the value of x is simply the determinant. In the denominator, we will have the determinant of the coefficient matrix for the variables. And for the numerator, what I will do is, for the very first column, we will replace the value that the left-hand sides take on the right-hand sides. Namely, because we are trying to calculate x, we are going to replace the first column entries with 29 and 2 versus the second column entries will remain intact. That's it. And let's quickly make a calculation for x. We have solved this problem previously. We found x equals 7 and y equals 5. Let's see if we can get to the same result. So 29 times minus 1 in the denominator. Let me write it out in the long form. Minus 2 times 3. For the denominator, it would be 2 times minus 1 minus 1 times 3. 29 times minus 1 is 29, minus 6, all divided by minus 2 minus 3. That's just minus 35 divided by minus 5, and indeed this comes out as a 7. Let's use the same technique to calculate y itself, the second variable. So the denominator will not change. Again, the determinant of the coefficient matrix on the left hand side, and what we will do is we keep the first column. The second column will be this time replaced with 29 too. Why? Because we are trying to compute the second variable. And on the numerator we get 2 times 2 minus 1 times 29. In the denominator we get 2 times minus 1 minus 1 times 3. The numerator as a result is 4 minus 29, all divided by minus 2 minus 3. That's just a minus 25 divided by minus 5, and indeed it comes out as a 5. Now what I will do next is to basically solve this same problem using Excel functions, the determinant function in Excel. So let me just go ahead and open the Excel application here. So I copy pasted the new formulation, the second solution here to that same problem. So let me write it out. Second solution, or third solution for that matter. What we decided to do is to come up with these determinants. So the denominators are the same. Let's just go ahead and calculate the determinant of the following expressions. We can start out with the determinant of the denominator, right? So the determinant will come out as follows. I will just write out the result over here. It's just a single number, right? So the determinant is equal to, so well, actually I can just go ahead and you find it from the formula. It's probably easier. So all I do is scroll down and find matrix determinant. So which cells? It's going to be, oops, there you go. I'll just delete that. It will be these entries. You guys see that? And that's pretty much it. It's already giving you the result. So the result is -5, and indeed when we calculated the determinant of the denominator, we got -5 in both attempts, right? So that's pretty good. We still have to find the determinant of the numerators for both expressions. So let's just go ahead and try this. So we have 29, 3, and 2 minus 1. The determinant for the first expression, so that will come out as, well, we can directly start writing out the function, and you can clearly see it. So all it's asking as an input is the matrix that we want to find the determinant for, and then just press enter. As simple as that. And all we need now is to take the ratio of these, and we will get 7 as usual. Alternatively, in the case of x, all right, so what I could have done is I could have done it in one setting, right? So it could have been the following: m determinant. So we could have first found the determinant of, well, yeah, so it would have been probably 2 steps, probably. So it would have been the determinant of the numerator, which is this monster over here, close parenthesis, divided by, again, m determinant. You guys see what I'm doing? I'm just calculating everything in one step, and then dividing by the determinant of the denominator. That's it. Close parenthesis, all the calculations together, x is equal to 7. So it's very convenient, and you guys can pretty much do the same thing for y, for the second variable, so which is the m determinant, matrix determinant for the numerator, which is, well, I didn't even write it out yet, right? So I need to first construct the array itself, which, yeah, I didn't write it out. So let me just do it in second step over here. Let's move that to the bottom here. First, let's find out the remaining determinant. The determinant of which polynomial, which matrix, this one, 2, 29, 1, 2. So I need to have like a placeholder for it if you want. I don't have to do it separately here, but I'll just do it anyways. M determinant. So our goal is to find the determinant of this. All right, and once you find -25, again, all we will do is -25 divided by this -5 will give us the 5. Alternatively, okay, so that's the solution I was employing here. We can calculate the determinant of the numerator, which is just basically the determinant of this monster over here, divided by m determinant, the determinant of the original coefficient matrix. And that will pretty much do. There you go, 7 and 5 again. So we found the value for x. Let me highlight it. And the value for y, highlight it again. And that solves this problem yet in a new solution. There is a third solution that I want to provide, and this one is also will make sense. I think you guys probably learned this method also early on. Let me go back to the original, the OneNote solution that we provided. Oops, let me just make it. All right, so this time what I will do is I'm going to start with these two equations, but I will give a visual interpretation. So it will be a geometric interpretation of pretty much the same thing. So let me just draw yet a new line. Copy these equations, 2x plus 3y equals 29. Oops. So we have 2x plus 3y equals 29. And also, so let's move it a bit more. And then x minus y equals 2. So the key idea is to have a look at the expression in the Cartesian coordinates. And it turns out because these are linear equations, they represent lines. in the Cartesian coordinates. That's why we call them linear equations, because they represent lines. Well, let's start by visualizing the first equation, 2x plus 3y equals 29. One thing to do is we can set x equals 0 and find the y-intercept, which will end up being 29 over 3, which is, as you can imagine, slightly less than 10. So if this is a 10, so 29 over 3 will be somewhere here. And if we set y equals 0, x will come out as 29 over 2, which is 14.5, right? So let's assume that this is a 15. So 14.5 will be somewhere there. Let me just go ahead and draw the remaining scale, because that will be useful. So that would be a 5, a 10, a 5 here, right? And I can even go further. There you go. I have the whole scale in front of me, so it will be easier to mark the points. There you go. There you go. And here we are. All right. So what I will do next is to draw the equation, the line, I should say, representing that equation. There you go. Now we can go ahead and start with the second equation. Oh, look at the bird tweeting. All right, so the second equation will be, I can just draw it by setting y equals 0. It will give me the x-intercept of 2, namely this point. And setting x equals 0, y will come out as minus 2. Now this one will be a little bit more annoying to come up with, but it's probably somewhere here. And now when I just draw this line as well, I will just focus my attention. So this is the second line. So the first line was 2, oops, sorry for that. All right, there you go. All right, so the first equation was 2x plus 3y equals 29. And the second one is x minus y equals 2. And the key idea is to look at after the intersection of these two lines, which is clearly this point over here. And indeed, that's the desired solution of x equals 7 and y equals 5, right? So that's, let me rewrite this one. X equals 7 and y equals 5. So that's yet a third solution. Now, the problem with this approach, though, is that for the other example that we provided, the 3 by 3 case, each of the equations will represent a plane. Indeed, 3 planes will intersect at a single point again. However, we will need a picture, a 3-dimensional picture, which will be very difficult to draw without like proper like software, I would say. So that's why one idea is to use Wolfram Alpha, but the things will be totally impossible to interpret if you have 100 equations and 100 unknowns, for example. So this is a nice visualization in the 2 by 2 case, but in other cases it can end up becoming problematic. Going back to earlier problems that we solved, remember that this was another problem that we solved, this 3 by 3 solving this equation. We solved it earlier in the 3 by 3 case. So what I want to do next is to provide a determinant solution to this one more time, just to make sure we have a good practice of what's going on, and that would be it. So I will just go ahead and open some space here. Let me also copy that question one more time. So there we go. So the question was to solve, let me write the original wording of the question as well. Solve the following system of equations: x plus y plus z, x minus 2y minus z, and 2x plus z were equal to respectively 3 minus 8 and minus 1. So what I want to do next is to find the value of x. Let's start with the value of x. The value of x will effectively be equal to the determinant, and that's how we represent the determinant sign, right? Both in the numerator and in the denominator. It's a little bit large, but all right, let's try to fit it in. So in the denominator, it will be the coefficient matrix 1, 1, 1, 1 minus 2 minus 1, and 2, 0, 1. In the numerator, it will be, what I will do is I will replace the very first column, because this is the first variable, with the numbers from the right hand side of this system of equations. So it will become 3 minus 8 minus 1. The other two columns are intact. Minus 2, 0, 1, 1, minus 1, and 1. There you go. Let me actually go ahead and remove all the other things. All right, that's it. That should give us the desired result for this one. And we can do pretty much the same idea for the y. The denominator will be again the same denominator, basically 1, 1, 1, 1 minus 2, 0, and somehow I ended up writing it column wise. Okay, so now we're going to replace the second column entries with this expression over here. So therefore it will end up becoming, so the first and the third columns are remaining intact, 1 minus 1, 1, but the second column will end up becoming 3 minus 8 minus 1, and we need to still calculate this. And finally, we need to do the same thing for z. Let me just go ahead and try to squeeze it in here. The third variable missing, so 1, 1, 2, 1 minus 2, 0, and 1 minus 1, 1. The only thing that will change will be the third column, 1 minus 2, 0. The third column entries will be replaced with the values of these equations on the right hand side, and that's it. And we need to make these calculations here. So we have not done if you remember the 3 by 3 determinant, it was kind of annoying. So that's why I'm not going to do it right away over here. And it makes more sense to solve this problem using determinants again, right? When I say determinants, using determinants in Excel. So all you need is to find out the determinants of these expressions in Excel, and that would be pretty much it. So let me just go ahead and open Excel. Okay, I just copy pasted our solution so far to Excel. So this was the problem we were solving, and we decided that these are the determinants that we need to calculate. And let's just go ahead and first, because all three denominators are the same, so let's start with the denominator, right? So we have this matrix 1, 1, 1, 1 minus 2 minus 1, and 2, 0, 1. All right, so we need to calculate the determinant here, which is very M determinant, right? So we've used this function many times. We want to calculate the determinant here. So across the board, all these determinants have the same denominator of minus 1. Next is the individual numerators. So for the numerators, so we have to rewrite these things. So determinant. You know what? I'll do even better. I'll just move this down below, just aligning it with the values next to x, right? So for the numerator, I'm just gonna do it aligning with the numerator over here, so it will be more visually appealing, right? So there you go. Minus 8, minus 2, minus 1, and minus 1, 0, 1. All right. So if you were to calculate the determinant of this thing on the numerator, that would come out as a 1. And indeed, lastly, x is just the ratio of these two, 1 divided by minus 1. X will come out as equal to 1 over minus 1, or in fact, let's just go do it like this. This divided by that, and that's it. So the answer is minus 1. If you remember our earlier matrix form solution, we found that x was -1 again. However, in this one, we use this matrix form notation, and this one is an alternative solution where we use determinants. So in a similar way, you guys can also calculate y and z using pretty much the same determinants. So I will just leave it to you to just make those calculations using Excel, the determinant function. Notice that y is supposed to come out as a 3, y equals 3, and z ultimately should come up as a 1. That's it. So those are the three values: x equals -1, y equals 3, and z is equal to 1. So hope you guys enjoyed this video, and looking forward to see you guys in our next lecture.